So the first question is, what is space? And that is a very good question. The 1 minute answer is we don't know. So one of our theories is that space and time, for that matter. So I should say, back in 1905, Einstein realized that space and time are not separate, but they're woven together into something that's often called the fabric of the universe, or more technically, space-time. So we think that there is a description of our universe which is just bits of information, basically, or qubits to be more technical, quantum bits of information that are entangled together into some sort of network. So space and time don't exist in that network, and then space and time emerge from that deeper theory. This is cutting-edge physics, but it's one of the pictures that we have for what space and time might be. What is the best bit of evidence for alien life? We don't have any evidence for alien life, is the answer. So in the past, so we've landed missions on Mars, for example, the Viking missions in the 1970s, there was some suggestion that there might be some chemical reactions that looked a bit like life, and then it turned out that it probably wasn't, because it's very difficult to distinguish geology and chemistry from biology when you don't know what the kind of biology is that you're looking for. And so the answer is we don't have any evidence of alien life, of life beyond Earth, but we're looking. What's going to wipe out humans first? If I was to guess, I would say humans, and that's not supposed to be a joke. I think that the biggest threat to our civilization is us. Beyond that, threats from space. So if a comet came in from the outer solar system, as they do, and it happened to be aligned with Earth, it happened to hit Earth, then there's nothing we could do about it at the moment. Most of the asteroids, the big asteroids that cross the Earth's orbit, we've mapped, but there are a few maybe that we haven't. We're looking, so we're actively trying to do that. And if we see that one of those big asteroids might collide in the future, then we've got a bit of time, 10, 20 years, whatever it is, so we might be able to do something about it. We're going to have to leave the Earth at some point and spread out into the solar system and beyond, if we manage to do that. But at some point, if we do that, then nothing's going to wipe us out. Is time travel possible? Great question. It's kind of obvious to say it's possible into the future, because of course that's what we're doing, we're moving into the future. It then gets interesting, because you say, well, why do we have to go into the future? Why can't I stop going into the future? Well, you can vary the rate at which you go into the future relative to someone else. For example, if I was to get in a rocket now and accelerate off, even at 1g, right, just a sort of acceleration I could take, and head off and end up traveling relatively close to the speed of light, and let's say go to the Andromeda galaxy, and then, which is 2 million light years away from the perspective of the Earth, and then turn around and come back again. If I go close enough to the speed of light, I could arrange it so I would age, let's say, a year on the outward journey and a year on the inward journey. And you could do that calculation. But 4 million years would have passed on Earth. So I would come back on that journey 2 years older, but I'd arrive at the Earth 4 million years in the future. Will we ever travel at the speed of light? No. So that's a simple answer. Anything that has mass cannot travel at the speed of light, but anything that is massless, that has no mass, has to travel at the speed of light. Photons travel at the speed of light, not because they're light, but because they have no mass. So it should really be called the speed of massless particles, and that's built into Einstein's theory. It was subsequently realized, basically. So will we ever travel at the speed of light? No, unless you have no mass, in which case you have to.